Okay, defining wavelengths, that's pretty straightforward. Okay, there are a couple of pitfalls there. Let's just talk through it. It's the distance from the peak of a wave to the next peak, right? So it's the peak on the next adjacent wave. I think that you probably get away with saying peak to peak, okay, but really we want to be saying which peak we're talking about, because I mean there's lots of peaks, isn't there, on a wave? Is it that peak to that peak? Nope. It's the peak to the adjacent peak, the peak to the next peak on that wave, isn't it? Okay, and you can see it doesn't have to be peak to peak, does it? It could be trough to trough as well. Okay, so if you want a more general description, it could be the distance from a given point on a wave to the same point on an adjacent wave. And obviously drawing a diagram, picture's worth 1,000 words and all of that. Drawing a diagram, it's not going to hurt, is it? Okay, next question. The equation linking wave speed, frequency and wavelength. The recognized symbols here, wave speed is V, the symbol for frequency is F, okay, and the symbol for wavelength is lambda. Okay, very straightforward calculation here. The velocity is given as 3 meters per second, frequency is 1.5, and the wavelength is the thing that we're trying to find. If you rearrange that, okay, then we'll find out the wavelength is 2 meters. Easy couple of marks for us there. Now you'll be delighted to know that this question here, because it's from all the way back in whatever this paper is, 2013, this question here we don't need to know about. The phenomena that you're seeing there is something called diffraction, and it got taken off your specification. It got taken off your specification, when the specification was revised.